Hello students, today we are going to talk about temperature and density. First we'll talk about temperature. There are three different temperature scales. There's the Kelvin, there's Celsius, and there's Fahrenheit. Kelvin, absolute zero would be 0 Kelvin, and that's pretty much the coldest that you can go. They have gotten a little bit colder, but it's pretty much the coldest you can go. We'll be working with Kelvin this year, and then we'll also be working with Celsius. And then Fahrenheit we'll talk about just because that's what you're used to. Those first two equations are equations that you will be given on the test, but you should write it down for your homework. And then the next two equations, I will give you the first one, but I will not give you this bottom equation. This bottom equation you need to know, or you need to be able to rearrange this equation above to get it. So now let's do some practice. The first one we're going to do is 100 degrees Celsius equals blank Fahrenheit. Now every single time we do math in this class, you have to first start with a formula, then you have to show work with units and answer with units. It's 1 point for the formula, 1 point for the work, 1 point for units, and 1 point for answer. So first we are looking for Fahrenheit, so we want to have Fahrenheit by itself, so the only formula that has that is your Fahrenheit equals Celsius times 1.8 plus 32. Then you want to fill in what you know. So we know the 100 degrees Celsius. So we've got the 100 degrees Celsius times 1.8 plus 32. If you put 100 times 1.8 in your calculator and then you add 32, you get 212 degrees Fahrenheit. What you should do now is I have two more examples. You should pause the computer and try to do both of those and then check your answers. So for the first one, we've got Celsius and we're looking for, we've got Fahrenheit and we're looking for Celsius. So you want to have the equation for Celsius that has Fahrenheit in it. So that would be Celsius equals Fahrenheit minus 32 times 0.555. Then you need to plug in what you know. Celsius equals 48 degrees Fahrenheit minus 32 times 0.555. This time you have to do the 48 minus 32 first and then multiply by 0.555. To get that you would get 8.88, and it actually would be degrees Celsius. I forgot my degrees said. Next, if you have not done the next one, pause it, try it, and then we'll go through it. Next we've got 32 Kelvin equals Celsius. So we've got Celsius again, but this time we've got Kelvin. So you want your other equation, which is Kelvin minus 273. So then you want to plug in your stuff. So it would be 32 Kelvin minus 273. And 32 minus 273 would be negative 241, once again, degrees Celsius. There is a degree for Celsius and Fahrenheit, but Kelvin does not have a degree symbol. So that is it for temperature. Now we're going to move on to density. Density is the ratio of an object's mass to its volume. Density does tell if an object's going to float or sink. If it is less dense than whatever it's in, it will float on top of more dense. So that explains like oil and water, why one of them floats and one of them does not. Or ice and water, your ice is less dense than your water. The equation is density equals mass divided by volume. Now this equation I will give you on your test, but I will not rearrange it for you. So on your test I will probably write it as D equals M over V, but you do need to know how to rearrange this equation. If we wanted to solve for mass, we would need to get rid of the volume. And so to get rid of the volume, you would, I'm going to rewrite this so you guys can rearrange it. We would want to multiply by volume on both sides. That cancels out the volume. And so mass is equal to dV. Make sure this equation gets in your notes because I will not give that to you on the test. Then looking at that equation, if we want to solve for volume, we need to get rid of the density. To get rid of the density, you want to divide on both sides. That gets rid of the density. So volume is equal to mass over density. If we're looking at units, the units for these, density is either in grams per milliliter or grams per centimeters cubed. Your mass will be in grams, and your volume will be in either milliliters or centimeters cubed. So now let's do some example problems. First, what is the density of a mineral if it has a mass of 105 grams and a volume of 30 centimeters cubed? So remember, once again, you first need to write the formula. So we're looking for the density. So we're going to start with D equals M over V. Then we plug in what we know. So the mass is 105 grams, so that will go on top. And the volume is 30 centimeters cubed. You'll do what the problem states, which is to divide. So 145 divided by 30 is 3.5. The units for this, none of them cancel out, so we'll be left with grams per centimeters cubed. I have another example. You should pause it and then restart, pause it, try it, and then see if you're correct. What is the mass of a sample if the volume is 28 milliliters and the density is 1.4 grams per milliliter? This time we're looking for mass. So we're going to start with our mass equation. Remember, this equation will not be given to you on the test. So mass equals density times volume. You'll do your density, which is 1.4 grams per milliliter, times 28 milliliters. When you multiply the two, the 1.4 times 28, your mass will equal 39.2. The milliliters cancel out, so you're left in grams. I do have one last example. You should pause it, try it, and then see if you're correct. What is the volume if a liquid has a mass of 58 grams and a density of 0.85 grams per centimeters cubed? So this time we're looking for volume. Volume is mass over density. Remember, I will not give you that equation on your test. We've got 58 grams over 0.85 grams per centimeters cubed. This time our grams cancel out, and our answer, if you take 58 divided by 0.85, is 68.2 centimeters cubed. That is it for today's notes. After that, we'll do section 4 next time. So we will practice more with these tomorrow.